Hi, Mrs. Young here, and today I'm going to be talking about creating and naming ionic compounds. So before we can actually talk about ionic bonds and ionic compounds, we need to talk about what ions are. Ions are atoms with a charge. The charge can be positive or it can be negative. On the left-hand side, you see a positive ion. It's positive because it shows that there are 3 protons and only 2 electrons, so it has more of a positive charge than a negative. And then on the right-hand side, we have a negative ion. That has 2 protons and it has 3 electrons, so more electrons means it has more of a negative charge. If an atom doesn't have any charge, then we don't call it an ion. So the noble gases, they're neutral, they have no charge, so they would not be considered ions. So let's look at how the atom charges line up on the periodic table. The charge of an atom is going to correspond with the number of electrons that it actually needs or wants to give away. So if we start with group 1, the alkali metals, you'll see that they all have a charge of +1. When you move over to the alkaline earth metals, you'll see it has a charge of +2. We kind of just skip the transitional metals because their charges can vary. Then we pick it back up with boron. Boron has, and that family has a charge of +3. Once we get to carbon, remember carbon has 4 valence electrons. So it can either take 4 electrons from somewhere else, from another atom or other atoms, or it can get 4 atoms or give away 4 electrons. It's easy, it doesn't matter, either way is the same effort. So then we move on to the nitrogen family. This is where you have 5 valence electrons. It's much easier to try and take 3 electrons to get that full outer shell of 8 than it is to try and get rid of the 5. So that has a charge of -3. Oxygen family has a charge of -2. The halogens have a charge of -1. And then once again, the noble gases, they don't want to get electrons, nor do they want to give them up because they're full, they're happy, 8 is great, and so they have no charge. In general, metals have a positive charge. They have electrons to give. So if you look at the sodium in the picture, remember sodium has 1 valence electron. It wants to get rid of that electron. So if normally an atom of sodium would have 11 electrons, but if you got rid of that 1 outer valence electron, then you'd have 10 electrons. But remember that sodium has 11 protons, so you would wind up having more protons than electrons, so that's what gives it that positive charge. So let's look, all alkali metals, that family has a charge of +1. All alkaline earth metals have a charge of +2. So if all metals are positive, then that means nonmetals have a negative charge. They need electrons. So if you think about chlorine, that's a halogen. It has 7 valence electrons. All it needs is 1. So if it gets that 1 electron it needs to make a nice full outer shell of 8, now instead of having a total of 17 electrons, it has 18 electrons. Well, if we think about how many protons a chlorine has, it has 17. So that means that there would be more electrons than there would be protons. So you would have a negative charge. So that's kind of how the charges come about. So halogens, they all have a charge of -1. The oxygen family has a charge of -2. So why does that matter? Why do we care about atoms with charges and ions? Well, it's that attraction between the positive and negative charges that will create an ionic bond. So we remember from kindergarten, opposites attract. Well, it's the same way in chemistry. The opposite charges attract each other and we get this ionic bond, the transfer of the electrons. So let's do some bonding time. When it comes to ionic bonds and ionic compounds, we're going to start with the metal, that positive metal ion. So in this situation, let's go with sodium. Sodium has a charge of +1. Now we need a negative charge, so we're going to get that from the nonmetal. So for this example, we're going to use chlorine. Chlorine, being a halogen, means it has a charge of -1. So now that attraction between positive and negative will create an ionic compound, create an ionic bond. So there's your sodium, your positive, there's your chlorine, there's your negative, and now you have an ionic compound. So in general, think of the rules for ionic compounds being it has to occur between a metal and a nonmetal, and then the overall compound charges must equal 0. So sodium has the +1, chlorine has the -1, +1, and a -1 equals 0. So then how would we go about naming this and other ionic compounds? So we're going to start with the positive ion, the metal. So sodium, we use its full name, sodium. Then the negative ion is going to go next, the chlorine. Now we do a little tweak to that that negative ion. We're going to change the ending. We're going to change the ending of the nonmetal ion to "ide." So instead of being chlorine, it would be chloride, or fluorine would be fluoride, or oxygen would be oxide. So the name of this ionic compound would be sodium chloride, which is also known as table salt. So then how would we write that as a chemical formula? Remember, chemical formulas tell us two things. It tells us what elements make up that compound, and it tells us the ratio, or how many of each element. So for sodium chloride, you would take the elemental symbol for sodium, start with that, and the elemental symbol for chlorine, which is Cl. We have one atom of each, so we put it together and we have NaCl. So let's do another one. Suppose we had magnesium and chlorine. Magnesium has a charge of +2 because it's an alkaline earth metal. And then chlorine, like we already said, has a charge of -1 because it's a halogen. So looking at that, you can see that we have our metal and our nonmetal, but we don't have charges that balance. We have a +2 and only a -1. So we have to do something to make those charges balance out to 0. So we can do it by just adding another chlorine. So now we have the +2 magnesium and then the -1 for the chlorine, but we have 2 of them. So +2, -2 equals 0. And if we were to go about naming this, we would say magnesium chloride, because remember, you keep the name of the first metal, and then you change the ending of the nonmetal to "ide", so magnesium chloride. And then if we were to write this as a chemical formula, remember, a chemical formula is going to tell you what elements are in it, in the compound, and how many. So magnesium, we have 1, and then we have 2 chlorines. So it would be MgCl2. And I hope that was helpful.